Hi everyone, how are you guys? Well, I'm fine too. Thanks for asking. Well, anyway, welcome back to my channel. And today I wanted to share a project I was working on. Actually, I finished this one, but sometimes I take a look at it and do some tweaks here and there. Try to run some tests, and the name says it is a StarTrek Uniform classifier I built. I don't know if I have some other deep learning videos in my channel. If not, that's the first one. So yeah, we moved from machine learning to deep learning models and all. They're a little bit more complex, but they usually require a ton of data. That's why our model still isn't perfect or isn't nearly as good as it should. But let's take a look at it. I'll go quickly through the code here. For the data, I gather data from Google Images basically. I just searched for StarTrek Uniforms, basically these three classes, red, blue and gold, because the Star Trek divisions are divided by colors in their uniforms. So I used an extension to get the data, but we have some bad images or bad files that isn't good to our model. What we do here for feature engineering is basically we get rid of all the files extensions that are not JPEG or PNG, and we try to open the image with Philo and convert everything to RGB if they're not, and resize it to normalize the data correctly. Okay, we just run this function. I try to run it, so I need to run again. Here, just normalizing the data. They should be normalized by running this, but anyways, a double check. These parts are different from our machine learning models we were working on. We don't use train test split because we have validation dataset, not only train and test. Use image dataset from Digitory, from the Keras library. I allocated 20% for testing and validation, but that's the thing. I only downloaded nearly 200 and something images from each class. I guess that Operation Gold has fewer images than the other ones. This number here usually is a pretty small number for a deep learning classification. Normally you want thousands or hundreds of thousands of data, but that's what I have. So here I just run some tests to see if our image is good and if my files here are just fine. Because I had some images that were not the class it should be. Like for example, in my data here, some gold images were actually red and so on. So yeah, I just run some tests individually here to check that. We check for our normalization, our bed size, the image dimensions, and if it's RGB, so the channel colors. And that's the number of images we have. So come to the part where we build our custom CNN. I use basically three main layers here, composed by a convolutional and max pooling layer. So that's basically the standard for computer vision. Convolutional will detect the specific features using a filter. In this case, that's the size of our filter. That's the number of neurons. We usually start by a small value, then we add more, usually by multiplying it. And then max pooling will basically reduce the width and height, essentially reducing the spatial dimensions. Oh yeah, I forgot, by the way, we have some data augmentation because we have a few images here, so we pass some data augmentation to train, kind of to make more artificial images by flipping them and rotating them. So we're gonna flatten it to one dimension, then we're gonna pass the dense with ReLU. ReLU is the standard for hidden layers. Again, it's not the output yet. Dense will basically learn the relationship between the features. My model were overfitting, so I added some dropout here, basically regularizing our model, kind of that avoiding to memorizing. But then there's our output softmax, because multi-class classification. We have three labels we wanted to predict. Basically that's it, my custom model. Really simple one, but it works. Of course, I'm gonna use cross entropy, because again, multi-class classification. and a very low learning rate. We got some good numbers of parameters, and then we trained with 25 epochs. Later on, I used some callback function. Yeah, that's it. I have some evaluation and validation later. I used some pre-trained models as well, MobileNet and EfficientNet. Where is it? EfficientNet. Froze the layers and then unfroze some few layers to train, but they didn't perform well because of the data that is really small, and usually these pre-trained models, they require more data than the usual, and we don't even have the usual, right? So that's my early stop that I'm gonna pass to callback later. I guess I passed it here, yeah, but I didn't early stop it. I guess was to few epochs too. I tested with 50 epochs, but no kind of that lost the patience after some tries. I have this resume here, which is basically the summary of everything. So we're gonna see it here because it's way better than seeing the code. It's kind of messy in the code. So that's our classification. Not here. That's my classification report. The summary of every model after the validation already. So I run some k-fold cross validation to ensure that our results are not random. And yeah, as you can see, our custom CNN model will outperform the other two pre-trained, MobileNet 75%, and EfficientNet was close, but almost 5% of standard deviation, which is kind of worrying. It varies. It basically means that it varies much. So 85% is the mean, but so you know the tests across defaults were higher numbers and lower numbers, which is not good. We want our model to be stable, okay? So for this project, I built some website so we can kind of see our model working. Let me get some image tests to see here. So that's our model. I built using Streamlit. So let's test some images. Okay, let's get here, I don't know, blue, for example. These are images that were not trained on nor tested, okay? There's a blue uniform. We have some yellow here, some brightness, and some red colors. So let's see how our model is performing. We click Analyze, and it returns blue with 70% of confidence. Okay, probably because of the other color channels here, but okay, detected that the uniform is red. Well, basically that's it. We can try some red image. I prefer this one because we see we have a lot of yellow here, so you might predict yellow, maybe. Wow, okay, no, actually 99% of confidence for red. Interesting. Let's try with this one. So half blue, half red. Actually have a little bit more of red, so maybe our predictions will not be that confident. 85% of confidence. Okay, but yeah, you guys can download the project and run some tests here, test some images. Pretty simple to run. You just call Streamlit and run the app. Something I forgot to mention is the precision for each class here. For gold, the precision is higher than the other ones, and we have some good recall and FM score, so the false positives and stuff. And that's it, guys. I hope you guys enjoyed the project, the video. I'm learning more about deep learning models. By now I use it only Keras, and I'm starting to learn PyTorch, and I'll bring more personal projects and stuffs I do. Okay, well, see you guys later, and thanks for watching.